Hi, so last time we tackled regarding the integration by parts. So let me rewrite our formula using this technique. So we have the u dv is equal to uv minus the integral of v du, right? Okay, so see for our first sample, let us integrate the say we have x squared ln of x dx. Okay, so as you can see here, it is more complex than our previous samples, and we cannot directly use our basic formula to integrate this kind of integrand. So let's try to use this integration by parts. And we also said last time that it is usually used when integrand have some this type. So we have logarithms. Okay, so we have some function of x here, which is in terms of logarithms, and we have x squared. Okay, so in using this form, as you can see here, we need to set which is our u and dv, which is u and dv. Okay, so we say that it is suggested that the dv must be integrable. Okay, so first we need to assign some of this integrand into something into some u, then its derivative, as well as we need to determine the dv, wherein we take the integral of this, we have v, right? Okay, so we need to determine which is u and which is dv. Okay, we say that it is suggested that when we choose which is u and which is dv, then for dv it must be integrable. Okay, so which part here is integrable? Of course, the x squared is integrable, and ln of x here is also integrable. Ln of x is not it's not integrable. Okay, so we don't have the integral of ln of x, but we only have the integral of 1 over x, which is ln of x. But in case in this part, we don't know the integral of ln of x. That's why we can choose our dv as x squared dx, right? And then if we take the integral of this, then we will come up with v. Or if we take the integral of this, take the integral of this one, the integral of x squared dx, we have x cubed all over 3, right? And then since we let our x squared dx as dv, then what we have left here in our equation is the ln of x. Okay, so we will let our ln of x equal to u. Okay, so u. Then we when we take the derivative of this, we have du, and the derivative of ln of x is 1 over x, right? 1 over x dx. Okay, so since we already assigned some functions of x in terms of u and the dv, then let us now proceed to our main formula technique. So say that our UDV, this is our, let me rewrite this. We have our U is the ln of x. Okay, this is our U. And dv is equal to x squared dx. So we let this as our dv, right? So uv, integral of uv is equal to uv. What is our u? It is we have uv. Our u is ln of x, and our v is this one, 1/3 x cubed, right? So we have this one, uv minus the integral of v, then du. Okay, so again, what is our v? This one, we have 1/3 x cubed, and then our du is 1/x dx. Okay, you followed. So using our formula, the integral of u dv is just equal to uv minus integral of v du. And by doing that, we let our ln of x as our u and x squared dx as our dv. So we have u. So the integral of this is that we say that we need to multiply the u and v is 1 u multiply by v, then minus the integral of v du. So integral of v, which is this one, 1/3 x cubed multiplied by du, which is 1/x dx. Okay, so from here we can now simplify our answer. Which is equal to, of course we can copy this, or you can simplify this or rearrange some values, ln of x, then minus the integral of this. Let us move the constant outside the integral sign. So we have x cubed times 1/x, and we can now cancel out this. So we have x squared dx. Okay, so as you can see here, our udv and our vdu, as you can see here, our vdu is now more simpler than our udv, and that is the one of the suggestions last time, that the vdu, this part must not be more complex, or it must be simpler. Okay, this part must be simpler than our main integrand, which is in terms of udv, so that we can now simply integrate this integrand. Okay, so finally we can now solve this part, which is, let me copy the constant 1/3, then the integral of this is just simply x cubed all over 3, then our plus this sign. Then let's copy this. Have 1/3 x cubed ln of x. Okay, so this is now our final answer. Okay, so the integral of this x squared ln of x dx is simply 1/3 x cubed ln of x minus 1/3 x cubed over 3. Okay, Or we can now further simplify this uh, by uh, by doing some algebra. So let's take the 1/3 and what another. Okay, outside the term, and then what we have left here is only ln of x, then minus we move this outside the parenthesis, so what we have left here is only 1/3, right? And plus c. You can also end with this form. You may use this is also correct, but you can also use this form, again simplified form, okay? Or writing like this, you can also write like this. And so you have different options for your final answer, okay? So it's up to you. Okay. So once again, by using the integration by parts, we say that we need to choose which is u and our dv, and our suggestion is that we must set our dv that is integrable. So we cannot integrate ln of x directly, so we choose the x squared dx as our dv, so that if we integrate this, we can easily find the answer or our integrand, which is, if we integrate dv, then we have v. Then integrating this, we have x cubed over 3. Then since we choose x squared dx as our dv, then what we have left here is ln of x, and we can now use this ln of x as our u. Then if we take the derivative of this, then we have the du, and then if we take the derivative of ln of x, we have 1 over x dx, right? And then we change our main integrand into the form of the integration by parts, which is uv. Our u is ln of x and our v is this one, then minus the integral of v du, which is our v is this one and our du is this one, right? Then we simplify our v du, and then we proceed to the integration. Okay, so you can easily integrate this part, which is x cubed all over 3, and then we simplify our answer. Okay, so thank you, and I hope you learned something again from this video. Thank you for your time. See you on our next video.